Interval notation, the basics. This video will focus on writing the solution of an inequality in interval notation. Think back to when you learned to graph on a number line. If you don't include a point on the line, you used an open circle. And this happened whenever your inequality was less than or greater than. Okay? For interval notation, you will use parentheses, an open or closed parentheses. It's sort of like taking the open circle and cutting it in half, right? You got a parenthesis there, okay? That's how I associate it, okay? You may associate it or remember it a different way, but that's how I do it. Take an open circle and cut it in half there, and that goes with less than or greater than, okay? And it just depends on which side your x is as to which parentheses you use. Are you opening it left or right? Doesn't matter. It just depends on how your interval turns out. All right. If you do include a point on the line, then you use a closed circle. And that happens whenever you had less than or equal to, that's this one, or greater than or equal to, that's this one. So for interval notation, you will use a bracket, an open or closed bracket with less than or equal to or greater than. These are not necessarily in order. It depends on how the inequality works itself out and where you're shading that thing on the number line. So you have the equals. I associate the straight line equals with the straight line of the bracket. Okay, there's not. Again, I'm an associative person. If you're an associative learner, that spoke to you. If you're not, you're like, what did he just say? All right. So, but I think about taking an open circle and cutting it in half and having parentheses, and I think about the straight line equals goes with the straight line bracket. All right. That's how I remember those. So let's check some of these. So let's say that you've worked some inequality out, all right, and you've gotten x is less than or equal to 6. So what I want to do is I want to draw it on a number line and then write it in interval notation. The number line is not necessary, but I think it really helps to see. So for you visual learners, you're going to love the number line, all right. So let's look at this. X is less than or equal to 6. So when I look at this, what number do I put right here? And hopefully none of you yell at the screen 0, all right. Because you might have been taught 0 goes in the middle. Well, let me give you a secret here. A line is infinite, goes on forever. There is no middle. There's a middle to what I wrote on the board, yes, but there's not a middle. All right, and some of you, and don't do this either. Don't put 0, 1, 2, 3. 6 is okay. We could make that work. But what if it was 146? At Christmas, you'd be 142, 143. We'd be opening presents. All right, so here we got this. All right, so we're going to say 6. I only care about 6. It's the only number I care about. All right, I only care about the number 6. So just mark 6 on my number line. Which way this says less than or equal to? Which way is less than or equal to? Which way is less than? Less than is to the left. So I'm going to shade out here to the left. And when I get to the arrow, I like to shade what I call shade my arrow. I'll make a nice dark arrow. And some people, I've even seen students do this. Box it in like a big triangle here and make it look, nice or whatever. And they shade this even darker here, all right? However you want to do that to make sure that you know it's shaded. I kind of zigzag mine up and down, and then I darken the arrow. And when I darken an arrow, I always write beside it what that arrow represents. So here, this arrow is pointing to the left, so it is negative infinity. If it points to the right, that arrow is infinity, and to the left, it's negative infinity. Infinity and negative infinity are directions. They are not numbers. If somebody says, what's the biggest number you know, and you say infinity, you didn't answer correctly. Because infinity is not a number, it's a direction. All right. So this is negative infinity. It's in the negative direction, on forever and ever and ever and ever and ever and ever and ever. Take the smallest number you know and then subtract one, a smaller one. Okay. So negative infinity, and we go up to 6. So 6, look, does this have the equals on it? Yes. So am I using a bracket or a parenthesis? Straight line equals straight line bracket. So this time my bracket is going to open up. I'm going to make my bracket is this thing here. It's going to open up towards the shading. So my bracket opens to the left because I've shaded to the left, all right, from that number. So now when I write my interval notation, I'm going to start with negative infinity, comma 6, and then I have to determine brackets and parentheses on each one of those. So on the 6, this is the obvious one. This has a bracket, so guess what? We're going to use a bracket right here, okay? So we're going to put a bracket around the 6, okay? And then what goes around negative infinity? So if you remember, if you do not include the number, which infinity is not really a number, But if you do not include the value that's there, the thing that's there, you put a parenthesis. Infinity and negative infinity can never be included since they're not a number. So we have to put parentheses on it every time. Every time you have a infinity or negative infinity, you put a parenthesis around it. A parenthesis. So then x is greater than negative 1. So how many numbers do I care about here? I care about one number, and that's negative 1. So on my number line, I'm going to mark negative 1. I'm not going to worry about 0 or any other number there. I'm just going to mark negative 1. It's the only one I care about. If you start marking other things on there, let's say that you want to put 0 every time because that's how you were taught. And that's fine. I don't, but let's say you put 0 here and then you put negative 1 here. Now you've already missed it because you put negative 1 on the wrong side of 0. And you didn't even need to put 0 on the number line. You with me? So if you put it on the correct side, it's okay. But right there, you did something extra and you missed it because you did something extra and you put it on the wrong side. All right? So now you should know that negative 1 is to the left of 0, but I'm just saying sometimes you're taking a test, you get a little excited or anxious, right? And you make a careless mistake. Well, don't do anything extra. Not in that case. You can do all the extra stuff you want to in life, and people like it. You go get a job, you do extra stuff, they notice that. All right? But here, that's extra that you don't need to do at all. All right, so it doesn't add any value or anything to anything. All right, so x is greater than negative 1. So we're going to come over here and we're going to say to the greater than is to the what? To the right. So I'm going to shade out here to the right. And I get to my arrow, so I'm going to darken my arrow in. And this time, my arrow is pointing to the right. So what does that arrow represent? Infinity. Infinity. If you have trouble writing that sideways 8, don't do this. That's not really infinity. That's like an 8 that got punched and it's trying to stand back up. All right? So if you have to, draw 2 circles beside each other. But don't make them like the Olympic rings. That's not infinity. And don't make them like this, where they're way apart. That's like you drew somebody's glasses, right? All right, so look, don't do that. Just put them together. There we go. Or a nice sideways. Or, look, I've seen this. I remember this guy, friend in high school. He would take his paper and turn it sideways and write infinity. And he had some of the neatest handwriting I've ever seen in my life. He just couldn't write infinity. So he'd turn his paper sideways and draw an 8. Whatever it takes. Okay? So then here, does it have the equals? No. So then is it a bracket or a parenthesis? It's a parenthesis. So when we come down here, we have negative 1, comma, infinity. Oh, I didn't put that. Parenthesis here. Okay? So then that parenthesis goes here. So parenthesis around negative 1. And what always goes around infinity? Parenthesis, right? Always a parenthesis around infinity or negative infinity. So let's look at some more of these. X is greater than or equal to 0. Greater than or equal to 0. So what number do I care about? There you go. There's all you ones that want to put 0 there. There's you a 0. I did that one just for you. All right. So x is greater than or equal to 0. So which way is greater than? It's to the right. So we're going to come out here to the right. And I get to the arrow, and I'm going to darken my arrow in. And that's infinity, right? What goes around 0? That's correct, a bracket. Why does a bracket go there? Because of the equals right there. That's why the bracket goes there. No other reason on earth. Not because it's greater, not because it's 0, not because it's x, because the line's there. All right? So then I'm going to write 0, comma, infinity. And 0 gets what? A bracket. That's the easy part. That's what we have marked on our number line. And then we have to remember every time we have infinity or negative infinity, we have a parenthesis. And the way we know we include infinity or negative infinity in interval notation is whenever we shade an arrow right. That's right. We shade an arrow, either to the right or to the left. Okay, I was saying correct. Right. So anytime we shade the arrow to the right, we use infinity. Anytime we shade the arrow to the left, we use negative infinity. If we don't shade either arrow, we don't use infinity or negative infinity. Okay? So 0 to infinity in the bracket on 0. So let's look at the next one. X is less than 7. X is less than 7. So what number do I care about? 7. 7. Which way is less than? To the left. So we're going to shade to the left. And then we're going to darken my arrow here. And that arrow represents what? Negative infinity. Negative infinity. And what do I use around the 7? A bracket or a parenthesis? And why? That's right, a parenthesis. And why? Because there's no equals there. So now we come down here and we put negative infinity, comma, 7. And here's the deal before I write brackets and parentheses here. The deal is you have to put it in the order it appears on the number line. You can't put 7, comma, negative infinity. You have to put the smallest thing to the biggest thing within an interval. If you have multiple intervals, it really doesn't matter what order they're in, but typically you keep it from smallest to largest, left to right, all the way through, even a smaller interval to the left of a larger interval, although it's not incorrect to change them around. Okay, so then what goes around negative infinity every time? Parenthesis. And here, 7 gets a parenthesis. So negative infinity to 7, both of them have parentheses. All right. So let's look at some more here. X is less than negative 13. So what number do I care about here? Negative 13. Negative 13. So again, this is after you've solved the inequality, okay? So you've solved the inequality and you've gotten to the point where you're like, oh, guess what? I need to write interval notation. X is less than negative 13. So which way is less than? That's to the left. And I get all the way out to the arrow. I'm going to shade the arrow. And what does the arrow represent? Negative infinity, okay? So then I have what? Negative infinity, comma, negative 13. Right, you got to have negative infinity to the left of negative 13. Negative infinity is smaller than any number ever because it's the direction left. There is no number less than or to the left of negative infinity. All right, so here we have, let's see, parentheses around infinity and negative infinity every time. And on negative 13, I didn't put it on my number line. Let's go back. I skipped that part. There's no equals, so it needs to be what? A parenthesis. So I need to make sure I have that on there, right? So then parentheses goes around negative 13. Now, just as some bonus information here, I keep talking about infinity as a direction, not a number. This is bonus information. You don't need this for my algebra class and probably not anybody else's algebra class. But there are 2 sizes of infinity. There's a countable infinity and an uncountable infinity. So there's one infinity that's bigger than another infinity. Say what? I know. All right. So that's just bonus math information if you ever get it in a trivia game, right? X is greater than 3/11. So again, what number do I care about? 3/11. Wait a minute, Mr. I can put a fraction as, yep, you sure can. I mean, a fraction is a number just like negative 13 is a number, or 0 is a number, or 7 is a number. Why can't you mark 3/11? You don't have to do it. Look, I've seen students do this. They go, well, here's 0 and here's 1 and 3/11 is about right here. Okay, that's fine. You got 3/11 in the right place. It's between 0 and 1. It's closer to 0. Just mark 3/11. You don't need to put, that's extra stuff you don't need to do. 3/11. Which way is greater than? To the right. Shade the arrow. The arrow represents infinity. And then what goes around this? Parentheses. There's no equals. Now, before we go on any further, I want to finish this one and then talk about something. So we have 3/11, comma, infinity, and they both get parentheses here. So if you notice, all the ones we've done so far, I think we've done 6 of them on this video, all of them have the x or the variable on the left. It doesn't even have to be x. You can have m is greater than something, or d is less than something, or y is less than or equal to, or whatever. Okay, I just chose to use x's here, but I have my variable on the left. Now note what I'm saying here. I am not saying you must put the variable on the left, but I am saying I think it's easier to think about if you do that. It's so much easier for me to think about, oh, x is less than negative 13. What if I wrote it this way? If I wrote it this way, what's the alligator eating? The alligator's eating the negative 13, and that is so not proper math to say the alligator is eating something. Okay? But the alligator is about to eat the negative 13. So if I do that, that means it's got to be this way because the alligator's got to eat the negative 13. So then this is negative 13 is greater than x is how you read that one. So if I had to do that on a number line, negative 13 is greater than x, that maybe gets a little confusing. How do I figure out which side to shade and that kind of thing? So I like putting my variable on the left. If you have a teacher that makes you do that, fine, do it. I don't make my students do that, but I tell them that I think it's more it's easier to comprehend and understand what it is. Here's the other thing. Let's go back and look at all 6 of these. Notice what I'm saying here. If the variable's on the left. If, right? If the if falls apart, then the statement's not true, right? If it's raining outside, the game may get canceled, okay? Well, if it's not raining, then the game's not going to get canceled, not for rain anyway. So here, we're going to have if the x is on the left. X is on the left on both these. Which way does this thing point? It points to the what? Left. It's pointing this way. Guess where I shaded? Left. Which way is this one pointing? To the right. Which way did I shade? To the right. Points left, shades left. Points right, shades right. Let's look at the next page. Which way is this pointing? To the right. Which way did I shade? To the right. Which way is this pointing? Left. Which way did I shade? Left. Look at that. If the variable is on the left, your inequality will point to where you shade. Points left, shades left. Points right, shades right. That's pretty cool, isn't it? All right? But you have to have the variable on the left for that to work. I didn't say you have to solve for the variable on the left. I don't require that of my students. But I tell them it makes it a little easier because that thing points to where you shade when you have the variable on the left-hand side. So let's look at these two. Now, this looks a little different here, okay? 4 less than or equal to x less than 9. Well, this time x is between two numbers here, okay? So the thing is, I need to make sure this thing makes sense. Is 4 smaller than something that's smaller than 9? So is 4 smaller than 9 is how I could read that. Yes, 4 is smaller than 9. So this right here, this checks out and makes sense, okay? So since it checks out and makes sense, then I can keep working. If that said, for example, if this said 4 is greater than x is greater than or equal to 9, now is 4 bigger than 9? No, this is what we call nonsense. So you want to make sure it makes sense, okay? But that one makes sense. So if it makes sense, you can keep going. And this is called a compound inequality. And sometimes you work these things and you get a compound inequality. And I didn't deal with this. I'm not going to deal with this in this video. But sometimes you get 2 of the ones we've already done with an or between them. And you just shade one side and shade the other side. Okay? So, but here, this compound, I wanted to show you what happens when x is in the middle. All right? So here, I care about how many numbers? I care about 2 numbers. Now, you got to be careful. Don't just assume this goes on the left. You have to put them in the correct order. You know, smaller number on the left. So which one's smaller? 4, and the larger one is 9. And then x is in the middle, so guess what I do? I shade in the middle. That's where x is. X is in the middle, shade in the middle. Did I shade an arrow here? No. Do I include infinity here? No. Is x on the left here? No, it's in the middle, so I can't talk about shade this way and that way and point and all this other stuff. X is in the middle, shade in the middle. So then what goes around the 4? A bracket. What about 9? Parenthesis, because there's an equals here. That gives me the bracket. And then here, no equals gives me a parenthesis. So then my interval notation is 4, 9, parenthesis on 9, and what goes around the 4? Bracket. And then I have one more compound inequality here. I care about 2 numbers. -1 and 13/4. But before I go graphing it and just and on the number line and write down the answer, I need to make sure it makes sense. Is -1 smaller than something that is smaller than a positive number? So a negative number is smaller than a positive number. That's always true. So this thing checks out. I'm good. Okay. So again, if it said -1 is greater than or equal to x is greater than 13/4. Now is -1 bigger than that? No. So that's why that would be nonsense. Okay. So that's what I'm saying when I say check it to make sure it logically makes sense. All right. So then we're going to mark two numbers on our number line, -1 and 13/4. And again, the smaller number, -1's got to go on the left. Doesn't matter what order it is here. That doesn't matter. It's got to be smaller number on this side. Okay. So x is where? In between them. So shade in between them. And then tell me -1, bracket or parenthesis. -1 is a bracket because it got the equals. What about 13/4? And it doesn't always have to be the bracket on the left. It's just the way I did these two. So then it's going to be bracket, -1, comma, 13 fourths, parenthesis. Bracket -1, comma 13 fourths, parenthesis. So I've given you x is less than, x is greater than, x is less than or equal to, x is greater than or equal to. I did some fractions, that kind of stuff. You can use decimals, whatever. If if that's part of what you're working, they're numbers just like the other stuff. Square roots are numbers, things like that. There's all kind of stuff that could happen here. All right, I didn't address all those things. These are the basics. All right, you can put two of these things together with an or, like x is less than 1 or x is greater than 8. Okay, and you would just graph both those on the same number line. All right, so. In fact, I didn't plan to do this, but let's go ahead and do this. I'm just going to make that right now. Let's just do one of those. How about that? Let's just do one of those. So we're going to say, I'm going to do the one I just said. X is less than 1 or x is greater than 8. So, right, we did this on the first 6 and we did this on the first 6. We just didn't put them together. So let's put them together with an or and talk about what that is because that's important. Let's do that. All right, I have it in some of my videos, but let's talk about it here. All right, so here's my number line. All right, so if I'm working this one, what number do I care about? Well, I care about two numbers. Well, 1 is smaller than 8. But this time, x is not between the two values, right? It's not a compound inequality in that sense. It's two separate individual with an or between them. So when I look at x is less than 1 here, which way is less than 1? That is to the left. So let me shade out here. And this is going to be negative infinity. And then what goes around the 1? A parenthesis because there's no equals there, right? There's no equals there. And then 8. X is greater than 8. Which way do I shade here? Greater than is to the right, so shade out here. And this is going to be infinity, and then there's going to be a parenthesis there. A parenthesis. So how do I write this down? Well, if I start with my shading, I start way out here at the left with negative infinity. So I go from negative infinity, comma 1, and I have parentheses around both these. And then I also pick back up at 8 and go all the way up to what? Infinity. And again, parentheses around both. What is the math symbol, the interval notation symbol for the word or? Okay? This is why I should have had this on here. Because the symbol for the word or is union, down and back up, not the letter U. Look, if you did this, that's got a tail or a kickstand. That's not right. It's down and up. Okay, this is the union. Okay, this is the union. It means or. It's the math equivalent of the word or. Okay, and again, I addressed this in other videos, but I wanted to throw this one on here and show that. All right. So in fact, this is or. These here, these are and. These two are and. You can always write an and simpler. So we don't ever write and, or I don't ever write and. It's called an intersection, and it's actually the upside down union. The intersection is this right there. All right, but I don't teach it that way. I teach them compound inequalities. Here, the or, the union. So this is my final answer for this one. All right. So I hope this helps you if you have an inequality solved and you're trying to write it in interval notation. I hope this helps you accomplish that task.